Hello everyone and welcome back to the channel. In this video we're going to talk about similar polygons. So we have two triangles here, triangle ABC on the left and triangle DEF on the right. So we see a couple things about the triangles. Number one, we see these angle markings right here. Okay, so this is telling us that these angles are congruent, or down here kind of statement number one, for similar polygons, corresponding angles are congruent. Okay, so that's key. Anytime we have similar shapes, there was some kind of similarity transformation that took place. And this is known as a dilation. So our shape gets bigger or smaller. And so the angle measures actually don't change, they stay congruent. Okay, so that's one thing that we notice. Another thing we notice are these sides right here. So we have side A, side B, side C. But then when we look at our other triangle, we see side KA, KB, and KC. So what that K is, that is our scale factor, right? So K is our scale factor, or it's what we're multiplying our original shape by to get our new shape, okay? So when that's the case, corresponding sides are not congruent. They could be. If our scale factor was 1, then the shape would be congruent and similar. But most often the scale factor is not 1, so corresponding sides are what we call proportional. Okay, so we can use those two pieces of information to help us solve some problems involving similar polygons. So let's look at some examples. In the first example, we're going to look, we already have two triangles. The side lengths are given to us. We're going to write down which angles are congruent, which sides are corresponding, and what would our scale factor be. So our corresponding angles are going to be in the order that our shapes are named, right? So angle A is congruent to angle D. Angle B is congruent to angle E, and angle C is congruent to angle F. Okay, so those are our angles. Remember, our angles are congruent. Now let's talk about the sides. The sides are proportional. So we could say side AB over DC, right? AB over DE is equal to, we could say AC over DF. And then the last one would be BC over EF, okay? And the order of those don't really matter, right? As long as we have corresponding sides in that same ratio, okay? So now let's talk about how would we find K, okay? So let's assume that we're going from triangle ABC to triangle DEF. So to find K, we're gonna take the new shape divided by the old shape, okay? So our new shape is triangle DEF, our old shape is triangle ABC. So we're just going to take one of the sides. So let's just do, for example, side DF. So let's do DF divided by its corresponding side, which would be side AC. So we're going to say K is equal to 48 over 36. And we can reduce that. Both of those numbers are divisible by 12. So we can say this is equal to 4 over 3. Okay, so our scale factor, or what we multiplied 27, 36, and 21 by, is 4 over 3. Let's look at another example. Now it tells us that these two triangles are in fact similar. That's what this squiggly line means right here. And we want to find the value of x, okay? So we just need to look at the corresponding side where x is located, and let's write our ratio. So let's say 30 over x equals. Now you could write x over 30, that's fine. Since we wrote 30 over x, we need to now pick, let's just do 18 and 15. Now we have to write 18 on the top and 15 on the bottom, right? So notice how 30 and 18, they're from the same triangle. X and 15, they're also from the same triangle, right? We could have written it like this, x over 30 equals 15 over 18, and we're gonna get the same answer. The reason why is because we're gonna cross multiply to solve for x. So we're gonna cross multiply here and here. So we're going to say 18x equals, and we can do 30 times 15, and we get 450. Okay, now we can divide both sides by 18, divide by 18, and we get x equals 25. Okay, all right, last example. Remember in triangles, we do have these special line segments that form points of concurrency within the triangle. And one of those is the median of the triangle. So remember, the median is just the segment that goes from a vertex to the opposite midpoint, okay? So let's take a look at this example. We want to find essentially that segment right there, median BD. So they give us the side lengths of the triangles, basically split in half because this would be our median. So here we know this distance would be 60, and up here this distance would be 20, okay? So we could say 60 over, let's do 60 over 20 is equal to, now 60 came from triangle ABC, so I'm going to put x on top, and over here it gives us the median, which is 6, okay? So now we can cross multiply, and we can get 20x equals 360. We can divide both sides by 20. So we can do 360 divided by 20, and we get x equals 18. Okay, so that's a little bit about similar polygons.